In this video, we are going to see about naive Bayes algorithm concept in a by solving a problem. This video is continuous of naive Bayes algorithm. We already see some theory concept about nearby theorem. In this video, we are going to see with an solving the problem using naive Bayes algorithm. Let's take a data set. This is the data set which we have. This data set is providing some details about whether the person is going to play tennis or not, depending upon the weather condition. To consider this, in day 1, the outlook is sunny and the temperature was hot and humidity was high and wind was weak. Okay, because of this weather condition, the tennis will not be play on that day. Like that, depending upon the outlook, temperature, humidity and wind condition, we will decide whether the person should play tennis or not. Okay, let's take one of the feature from this data set. This is these four columns are independent variable and this play tennis is a dependent variable. Depending upon the input data, these 4 input data, it will give some output whether we should play tennis or not. Let's try to compute depending upon the outlook whether the person is will play or not. Let's decide the person will play or not, play the game or not. Let's take outlook. This is the event. In outlook, there are totally 3 categories. One is sunny, overcast and rain. We are going to compute probability for each event and their outcomes: sunny, overcast and rain. Here, whether the person is going to play, we will put whether the person is going to play or not. Okay, there are in outlook column, the person has played a game exactly. Here when sunny, the person is not played a game. Here also sunny, the person is not played a game. Another sunny is here, the person has not played a game. Here is also sunny, the person has played a game. That means the person has played the game when the outlook is sunny. That is was one, and there is another sunny. Here also yes. That means the person had played a game when the outlook was sunny. It's around 2 times. Like that. When then when outside is sunny, the person has not played a game 3 times. Like that, when the outlook is overcast, the person is the year is overcast, and corresponding outcome is S. And here also overcast and corresponding output S. Total 2 yes. When the climate is overcast, here also yes, and here also overcast and yes. Totally 4 times. When the outlook is overcast, totally 4 times the person had played a game, and 0 time does not play the game. Let's consider rain, and we will compute as we compute sunny and overcast. When it is rain, totally here is S, and here is also S, and one time rainy was no, and another rainy is here, and here also S, and another was totally 3 times. When it is rainy, the person has played the game, and 2 times he does not play the game when it is rainy outside. And let's compute probability of event divided by S. That means the probability of sunny while the person has played a game. That is was there are totally how many S, totally 9 S are there. Totally 9 S are there for the event. When it was sunny, he was played. That means 9 times S are there. When it is sunny, he has played 2 times. That means 2 by 9. When overcast is there, totally 4 times are he had played. The probability of overcast and when he played a game was 4 by 9. Like this, when rainy, the probability of raining while he played a game is 3 by 9. The probability of having an event and no, the player was not played a game, no, is when it is sunny, the person that not played a game is 3 by 5 and 0 by 5 and 2 by 5. Where compute this like this. Let's compute for temperature feature. Depending upon we already compute for outlook, like that we need to find for temperature. There are totally hot, mid, cool. There are totally 3 categories are there for temperature. One is hot, another was mid, and another one is cool. Let's find the probability for this event? Yes, no. When it is odd, the person has played totally. When it is odd, is not play the game. Here also odd, no play the game, and here is odd, he has played one time, and here is also odd, he is play the game. Yeah, they are totally two times he played a game when it is odd, and two times does not play the game when it is odd outside, not odd outside. And when the temperature was met totally four times he had played a game. Let's see here. Mid, yes, mid, yes, and here also mid, yes, mid, yes, and mid, yes, and mid, no. Okay, there totally four times he had played a game when temperature was mid, and two times he does not play the game when the temperature was mid. When it is cold, totally yes, no, yes, and yes. Okay, totally three times he had played the game, and one time he does not play the game when it was cold temperature, having a cold temperature. Let's find the probability of event by when he has played the game. When it was hot, he had played the game with a that having a probability of 2/9. For mid, totally four times he had played the game when it was mid, having a probability of 4/9. He has played when it was cool, when he was played is probability having 3/9. For the event by when he does not play the game, let's compute this. When the probability of odd when he does not play the game is 2/5. There are totally 5 no's. He does not play when it was odd is 2/5. For mid also 2/5. When cold is 2/5. Probability was 2/5. Okay, we all compute this. Let's put this data. By using this data, we will compute whether the person is play the game or not, and we need to compute another thing, the probability of playing a game or not. The probability of playing a game, there are totally 9 times. 9 times he has played. Okay, sorry. He has played a game is 9 times, total 9 times, and totally he does not play the game is 5 times. Let's compute probability for the playing game or not. The probability of playing a game is 9/14, because totally 14 times he had decided whether we have to play or not, totally 14 times. So the probability of playing a game is 9/14. 14, and probability of not play the game is not playing the game is 5 by 14. Okay, by using this data, let's compute the output by using probability Bayes theorem. The Bayes theorem says that we know the Bayes theorem formula. The probability of playing game when it was sunny and hot. Let's compute the probability of playing the game when it was sunny and hot. Is equal to probability of S into probability of sunny S and into probability of hot by S. This is computed from divided by probability of sunny into probability of hot. We derive this formula by using Bayes theorem. Okay, let's put the probability and we will calculate the output. Probability of S is 9 by 14 and into probability of sunny when sunny and he was played is 2 by 9 and probability of hot when he was played is 2 by 9 and the probability of we will ignore this because this was a constant value. It was same for both probability of S when it was sunny and hot and probability of no when it was sunny and hot, so that we can consider this as constants and we can ignore this by cancelling this 7, this and this was cancelled, and 2 by 7 into 9 is equal to 2 by 63 and we compute 0.0031 the value. Let's compute for probability of no when it was sunny and hot. Let's compute this. The probability of no, the Bayes theorem for this condition is probability of no into probability of sunny when it does not play the game into probability of probability of hot when he has no play the game divided by probability of sunny into probability of hot. let's put the value for this. After putting the value which we have already calculated, for probability of no is 5 by 14, and probability of Sunny when he does not play the game is 3 by 5, and probability of Art when he does not play the game is 2 by 5. After the denominator value is a constant value, so we can ignore that. After doing cancelling, we get 0.08, 3 by 35, and whenever we are dividing this, we will get this answer. Okay, we have get two answers: the probability of yes when it was Sunny and Art, and probability of yes when it was Sunny and Art is equal to 0.05, and probability of no when it was Sunny and Art is 0.085. The probability of Art when it was Sunny and Art, probability of no when it was Sunny and Art is 0.085. We need to compute the whole value, so after let's compute. To know the percentage of each event, we need to find the percentage by 0.031. This is for probability of yes when Sunny and Art, divided by 0.031 plus. To get the exact percentage value, we can do this. For this both event, we get 0.27 is equal to 27%, and for probability of no when it was Sunny and Art, the exact value is 0.085 divided by 0.031 plus 0.085 is equal to 0.73, and the percentage was 73%. So by comparing this, we can make a conclusion that the probability of I the probability of when the climate was Sunny and Hot, the player does not play the game, because the probability of not play the game when it was Sunny and Hot is I when compared to S. So the final output is no, because the output is no. When it was Sunny and Hot, the player does not play the game. It was the prediction and the conclusion for this problem. Does not play the game. Okay, like this only the Bayes theorem uses probability, and Bayes theorem, Navie theorem uses the probability and Bayes theorem to compute the compute a prediction, or to make a decision, or to make a conclusion. Okay, we can see tomorrow with another algorithm. Thank you.